Welcome to the Weather Ready YouTube channel. Our first video on this brand new channel is going to discuss the winter weather outlook for 2019 to 2020. And I'm a senior meteorologist and been forecasting the weather for over 26 years. If you'd like to subscribe to our channel, please click on the subscription button below. And don't forget to press the bell so you can get new content when they're published. And also, I'd like you to like and share this with your friends and family. We'll start off with a trivia question. How many consecutive mild winters did the DC metro area experience? Any guesses? Well, the answer is 4. Previous winter temperature departure, if we go back to 4 years ago, December to February, and we define winter as meteorological winter from December 1st through the end of February, and that was December 2015 to 16, almost the whole continental U.S. was above average. If we go to the very next winter, December to February 2016 to 17, it was below average temperatures in the Northwest and above average for the Southeast 2/3 of the country. The next winter, December 2017 to February 2018, it was above average in the West and the Southeast and below average in the North Central U.S. and also in East Texas. And then last winter, it was below average for the Northwest, almost half of the country, and above average temperatures in the Southeast. To perform a forecast, I usually look at ocean sea surface temperature anomalies. Looking at the globe, over the oceans, we have very warm Northeast Pacific sea surface temperatures, and you can see that's 2 to 3 degrees above normal, and that's the warmest sea surface temperature anomalies across the globe. Now, we had similar winters that had that driver, the warm Northeast Pacific, and that was the winter of 2013 and 14, and you can see the warm Northeast Pacific. And what did it produce? November to March, below normal temperatures in the eastern half of the country and above normal temperatures in the west. Also, the very next winter, the same signal existed, and it produced almost the same type of temperatures. Cold temperatures for the winter, actually going from November to March, and warm in the west. I want to look at more than just one sea surface sector driver. So let's look at 4, the Northeast Pacific. Also, we have what's called a neutral ENSO, meaning it's neither La Nina or El Nino. It's neutral. Also, we have very warm temperatures in the Gulf of Mexico and up the East Coast. And the 4th driver is the cold North Atlantic. So if we look at all the different cases that fit those sector drivers, I came up with 7 winters. So if you plot all those cases together, you get an average sea surface temperature looking like this. If you go to the NSEP reanalysis chart, and that looks very similar to what we see today. So that's a good analog. Also, we want to see what kind of impact this produces. In the Northeast specifically, those 7 analog years produced what's called 8 NESIS winter storms. The NESIS stands for Northeast Snowfall Impact Scale, and it's a scale used to categorize winter storms in the Northeast United States. The scale was developed by meteorologist Paul Cosin and Dr. Louis Uccellini, and ranks snowstorms from Category 1, which are notable, to Category 5, which are extreme. If we look at those 7 analog years, we had some impactful Northeast winter storms. The first one was January 21st to 23rd, 1987. It was a Category 3 on the 1 to 5 scale, and it produced a swath of 10 to 20 inches from southwest North Carolina up the East Coast into New England. And then just a few days later, another Category 1 NESIS storm impacted the Mid-Atlantic with a swath of 10 to 20 inches. And then February 22nd and 23rd of that year, another Category 1 NESIS storm with a swath of 10 to 20 inches across the Mid-Atlantic. In 1994, we had a Category 3 NESIS storm where there's 10 to 20 inches across southern PA, New Jersey, and up into southern New England, with the most in eastern Massachusetts with 20 to 30 inches. And then probably the biggest of all the storms was the President's Day storm of February 15th through 18th, 2003, where we had a swath of 20 to 30 inches and some pockets of 30 plus inches of snow, and that was a Category 4 NESIS storm. In 2005, we had another Category 4 NESIS, which was a strong clipper and then turned into a northeast winter storm, where again eastern Massachusetts got over 20 inches of snow. And in 2014, January 20th, 22nd was a Category 1, where we had 4 to 10 inches across the mid-Atlantic and pockets of 10 to 20 in New York and southern New England. In February 11th through 14, 2014, there's a Category 3 NESIS storm, another swath of 10 to 20 inches up through the mid-Atlantic into the northeast. So let's look at these decadal NESIS winter storms and see what's the number per decade. So if we look at the 1958-59 through late 60s, we had 10 of these NESIS storms. Late 60s to late 70s, we had 7. In the 10 years from 78 to 87, or 79 to 88, we had 6. Late 80s, late 90s, we had 5. And late 90s and 2000s, we had 7. So you can see we average about anywhere from 5 to up to 10 NESIS storms every decade or every 10 years. What have we produced this year, or the last 10 years, since 2008 and 9 up into 2017 and 18? 29. So that's almost 3 times the maximum number of NESIS storms per decade. And I think a key driver are those warm sea surface temperatures, which give you increased water vapor to energize the northeast winter storms. So let's look at what NOAA's National Weather Service is forecasting for winter 2019 and 20. U.S. temperature outlook, they're forecasting equal chances of above, below, or normal temperatures across much of the north central and into the western northeast, especially around the Great Lakes, with above normal temperatures in the south. The precip outlook, we have the swath of above normal precipitation during the winter months across the northern tier of the U.S., dry along the southwest, mainly California, and dry in South Texas, and above normal in Alaska. So let's look at what causes patterns to produce either warmer or colder than normal temperatures. Well, we look at what's called the Arctic Oscillation and North Atlantic Oscillations, or the AO and NAO. And the positive or warm phase is when you have low pressure across the northern latitudes and high pressure in the central latitudes. And that usually produces westerly mild Pacific flow, where you have mild stretches of weather. When you have a negative or cold phase of the AO or NAO, you get high pressure in the northern latitudes and low pressure in the mid-latitudes, and that allows for the jet stream to bubble up into Alaska and bring frigid Arctic air into the central and eastern U.S. with potential for northeastern storms, and you get blocking over Greenland. You could put this together several months ago, and if you put those 7 cases for the month of November, we get that ridging over the northeast Pacific and troughing over the upper northeast into the east. So that would be favorable for trough in the east and ridge in the west, which produces this type of temperature forecast departure, where almost the eastern 2/3 of the country are below normal and just above normal temperatures in the west and Florida. So where are we at now? The actual temperature departure from normal this month ending November 28th looks a lot like those analogs, doesn't it? Where it's been warmer than normal in California in the west and well below normal in the eastern 2/3 of the country. So the analog for November is working very well so far. So if we can trust it for November and we trusted previous winters, we can trust it for the entire winter. So if we have the right analogs, this is what the jet stream pattern would look like, or at least 18,000 feet, the steering flow for this upcoming winter. warm sea surface temperatures, it produces a ridge over Alaska, which allows the jet stream to dip into the east, lower than normal heights with low pressure over New England and the upper parts of the Great Lakes, and that should produce colder than normal temperatures in the east. Let's break it down by month. The temperature forecast departure for December is warmer than normal in the western two-thirds of the country and near normal to slightly below normal for the upper Great Lakes and northern New England. And then pattern turns colder. Using those 7 analog years, January turns much colder in the east, especially the Great Lakes and New England and down in the northern mid-Atlantic, and warmer than normal in the west. February, it gets much colder in the east of the Rockies and the northern tier, and the warm spots would be in the Utah and parts of the Great Basin and South Florida. So if you put all those temperatures together into December through February, we get above average temperatures in the west and below average temperatures in the northeast and mid-Atlantic. What about the precip forecast for this winter? Well, with the trough in the east, you would expect above average precipitation. You get that deep polar flow and it comes up the east coast and produces above average precip. In the west, with the warm sea surface temperatures and blocking ridge, it inhibits big storms to come into the west. So I'm expecting below average precip for much of the west coast. What about snowfall? Well, with the trough in the east and the ridge in the west, below average snowfall in the west and above average snowfall in the northern, say, two-thirds of the country east of the Rockies. So that is the winter outlook for 2019 and 20. If you have any winter questions, please feel to post on the YouTube channel. If you like this type of weather content, and we'll update it ahead of big storms as the winter progresses, please feel free to subscribe to our channel and hit the bell. That way you get the latest update on videos, and we would like you to like and share with your friends and family. That is it. I appreciate your attendance.